If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in basic level where we are building concepts on definite integral. So in this lecture we will be seeing some of the key points or remarks about definite integral. We will see different types of Riemann sum and different conditions of area under the curve, some fundamental theorem of integral calculus and some properties of definite integral. Okay, then let's see this. Some of the remarks from that Riemann sum, that definition. The symbol, that snake text type symbol, was introduced by Leibniz and is called the integral sign. It is an elongated S. This S is written as, you can think that S is traced. Because why it is chosen? Because it is the limit of sum. So what you are doing, you are just summing, you are just adding this, all these areas, summing. So sum means S. From that S, if this integration sign capital S, if you stretch it, it becomes like this symbol. So from that is this symbol came. So in this formula, this fx is known as integrand, and is a and b are, a is the lower limit, b is the upper limit of the integration. The procedure of calculating definite integral is known as the integration. The definite integral a to b fx ds, the number, it is a number because you are getting the area, you are adding all this area, you are getting that area. It can be positive, it can be negative, it can be 0. It does not depend on the variable x. So you can change this x anytime. You can write this, all these are same. This x variable doesn't make any sense. You can change it to t, you can change it to u. Ultimately it will give you the area, that is number. There are other Riemann sum. Method 1, method 2 you have seen. So this is method 1, this is method 2. So what was the method 1? Method 1, the idea was to take this height. Method 2, the idea was to take this height. Method 1 was giving less in case of increasing function. Method 2 was giving more in case of increasing function. The another idea is you take somewhere a height which is in between these two, not this, not this. So one is taking this as a rectangle, someone is taking this as a rectangle, and now the new idea is to take some height at a point between these two and take this as an area, so that it gives me another way of representing. So what height you are taking, that gives you another way. So that is another way of writing another Riemann sum. Again n tends to infinity b minus a. Now this height is xr, some height at this is xr. What is xr? Xr represents the midpoint of this rth subinterval between x r minus 1 to xr. So between these there is a point, midpoint. So at this midpoint, what is the height? So instead of taking this you take the midpoint height. So that is also another way. But generally we take the method 1. You can take any one. Now if fx is continuously increasing in a to b, that is greater than 0, then the definite integral not increasing, it should be greater than 0 means it is positive, it is not coming below x-axis. It can be something of this fashion also, it can decrease also, but it should be above x-axis. It is positive, then the sum definite integral, this area will be also positive, because if you take this one also, the area is always positive. This represents the area under this curve y equal to fx, the x-axis, and these 2 points x equal to this area. Now if fx is greater than 0 in a to c and less than 0 in between c to b, so it is something of this function now fx. So you can see this area 1 Riemann sum will be positive, because you will be, these heights will be positive, but here the function value will be negative. So the area that you will get, because you will be multiplying by these heights. What is this height? These are the heights. This is width and this is height. So if it is coming below, this will give you negative sign. So all these will give you negative signs, all these heights. So this will give you a negative sign. So the Riemann sum here a1 will be positive, here the Riemann sum will be negative. So integration a to b fx will give you the, if you directly integrate from this to this, it will give you area 1 minus area 2, because this is negative sign. So ultimately from this area will get subtracted. Now if you require to find the sum of both area, if you want to find a1 plus a2 total area, then you have to modify it. From a to c it is okay, positive. From c to b, because your original integration is negative, so you put one more minus, so that this area gets added. Because a2 is, this will give you a2, Riemann sum will be negative, so that minus this minus will add these two areas. So that is the idea. So you break that in 2 parts, then you start from again from c to b. Now if you need, in this case, suppose this is the curve, you need now a3, this area on the y-axis. So what you do, you take inverse of this original function y equal to fx, so you take inverse means x and y will change. So x will be equal to f inverse y, so it will be something function of y. Now it will be, you can vary now y, because it is a function of y, so it will be c to d, that function of y. You integrate this function of y from this to this, so you will get this area. So that is also another way to getting this type of area. Now suppose you need this area, so what you do, you take the area of the upper one minus you take the area of the lower one. If you subtract, you will get the area in between these two. So that is the area A to B. The upper one is f1x, you take this area minus f2x. So it is integration A to B f1x dx minus integration A to B f2x dx. You can club it together because this integration plus minus you can separate. We will see in properties. So that's why it is clubbed together. These are all about your definite integral as a limit of sum or the fundamentals or definitions. Now let's see some of the, so in graphically we don't do this integration graphically. So what we do, or what is the easiest way to do this, calculate this definite integral? Let's see this one. It comes from this fundamental theorem integral calculus. Two theorems are there. Part A, if fx is continuous in A to B, then the function defined by gx, which is integration of function, take any variable, but you should go from A to x, that is from the starting point to any point in between that two, will be a continuous and differentiable in A to B. So that means you can take differentiation of this one. So the beauty is differentiation of this one will be this. So you can think of that, that means it is differentiation of g is x. That means fx nothing but the derivative of gx, and gx is nothing but antiderivative of fx, reverse of derivative. Because if you derive gx, then it becomes fx. So if you come back, if you take antiderivative of fx, that becomes gx, reverse one. So that is the idea. That's why the antiderivative sign came. That is the indefinite integral concept. Now part 2, if fx is continuous being A to B, then from A to B fx dx. Now this area that's known as Leibniz rule. And it's very fundamental theorem. This is very important to understand. Suppose this is my function. If you want to calculate A to B, this area, you can move along this path and you can find this total area. Or there is another way. You take antiderivatives of f, that is come to its original function, that is this one gx. Come to its original function from where this differentiation came. Differentiation of capital F is small f. So you are taking antiderivative of f, come to this new function, not this one. Back to its new function. That means you take antiderivative of this one, come to another function. You don't know what will be the shape, any shape. It will change because new function will come. And you take only these values at this point only. fb, this minus this will give you the area. Instead of taking the entire path, you are taking at the extreme points, that is B and A. That is B and A. So that is the idea, fb minus fa. So instead of looking at the whole function, if you remove this snake, that means you come back to the original antiderivatives of this one. You look at these extreme boundary points. So upper boundary minus lower boundary. So you remember this one. So that is nothing but you take antiderivative of this one and put these boundaries. Where fx is the antiderivatives of fx. So first you find the antiderivative, like that means first you find indefinite integral, then you at the end you put this limit. First you put upper limit, then you put lower limit. That means the differentiation of capital F is small s. So the evolution of definite integral, it depends on finding the antiderivatives of this function. That's why we studied antiderivative earlier. Antiderivative is nothing but indefinite integral. So that's why we started indefinite integral, because for calculating definite integral we need indefinite integral. Now some properties of the definite integral. This one we have seen, because definite integral give me only the number, so it doesn't make sense if you put x, y, t or y, whatever. You can change the variable anytime. A to b fx dx is minus b to a fx dx. That's you can easily understand, because if you go, because it is always upper limit minus lower limit. So if you change this position, if you take minus common, then it is fa minus fb. Then this position can be changed. From this fundamental theory also you can find it out. So it is b to a, that's why minus. A to b k dx, k is a constant. If you integrate 1, that is x. So if you can now apply here the definite integral. So k, it is a to b. K integration dx a to b. So it is 1. What is the integration of 1? X. And you put this limit. We write it in this way actually. This means the upper limit. So it will put, first you put instead of xb, then you put instead of xa. So this is your answer. That's why it is k into b. Now that's what I have told you. If it is a plus minus, you can segregate this integration separately. If c lies between a to b, then you can segregate it. Instead of going directly from a to b, you can go from a to c, then take a break, then you take from c to b. Like this one, a to c, then you can go to c to b. If fx is greater than 0, then this integration is also greater than 0. We have already seen from that graph, this one. then this area will be always positive because your function is positive. If your one function is greater than another function, then this area will be obviously greater than this area. Suppose this fx is always greater than gx, so the area, if you take this area, will be obviously more than this area. This is f, this is gx, because f is more than g. So the area under this curve will, in case of f, will be more than g. If m and r the minimum and the maximum value of fx in AB, then this is in between these two. Why? Because it is obvious. You can say, suppose this is my capital M, this is my maxima and minima. So this is A, this is B. So if you take this one, M into B minus A. So what is M into B minus A? B minus A is this length. So if you multiply this, you are getting this area. And what is capital M is this height, because it is maxima. So if you take this one, you are getting this area, total area. So actually these two are, what is your required area? What is this integration? This integration gives me this area. So this area is in between this area. This one is the smaller area. So your required area obviously greater than this small rectangle, and this area under this curve is less than this area. So that's what we have. This is actually method 1, method 2 of this concept. So you can easily understand. Now from here actual these properties come. Minus a to b fx dx is, if it is even function you have seen, then you can split this interval from minus a to a. If instead of going, you can, because even is symmetry, whatever this side, same side will be their side, because you have seen what is even function, cos x is even function. So if you go from 0 to pi by 2 or 0 to minus pi by 2, it will give you same area. So instead of calculating whole area, you calculate this area and multiply by 2, because both sides it is symmetry. So that's why it is, you take only 0 to a, then you multiply this one. This side there is no need, because this is the symmetry of this side only. And it is 0 in case of odd function, because odd function it is, you think of sin x. So 0 to pi is this area, 0 to minus pi. So if you add this from here to here, if you integrate, this will be 0, because this area is negative area, it will come. We have seen. So if you directly integrate from this to this, it will be 0. So that is in case of odd function. Now this is very important. 0 to a fx dx is 0 to f a minus x dx. You can prove it by taking a minus x equal to t, but I am not showing it here. This is also known as king rule, very important rule. And whenever there is a king rule and queen rule, this is easy way to remember. We always try to learn a line. Whenever you say king rule, you say king rule ला के add कर दिया, queen rule ला के add कर दिया, because you will see this proof is very important in a board exam also. Whenever king queen will be there, you always remember king rule ला के add कर दिया, because ultimately you have to add. You have to take I is equal to this, then you add this. So this is king rule, and you see your queen rule, a plus a to b fx dx is a to b f of a plus b dx. So it is same, because it is, if your b is 0 plus a minus x, upper limit minus lower limit plus lower limit minus x. 0 plus a is a, so it is a plus b, upper limit plus lower limit minus x. Both are same, but king is very specific, it is 0 to a, and it is more generalistic. There is another way of even odd, the little extension of this one. 0 to 2a fx dx is 2 into 0 to a, again no need of going up to 2a, if f 2a minus x equal to fx, which is something short of that even function. And if it is odd, 2a minus x is minus fx, something sort of odd, then it will be 0. You can remember from that way. Now this one is very, again, an important one. If you take the mod of this integration, that will be less than this. Why it is saying so? You are taking mod means obviously it is negative, that's why you are taking. So that's why I am taking this area, a to b suppose. So you are getting this area. So if you take mod area, you will get positive value of this one. So what this is, now you will see it will equal. Now if you take mod of this function, this was your fx. Now what is the mod of fx will be image of this one, because we have seen mod means image. So both this area is equal. Now you can say it is equal. So why it is given less than? It can be less than if it is a lower and upper bound. Suppose this is from a to b. There is positive also. Now if you add from this to this, because this negative is more, so the answer will be, suppose this area is 5, this area is minus 10. So if you club these two area, you will get minus 5, and if you, because it is 5 minus 10, then you club it. So what will be? It will be minus 5, club it 5, and don't take it 5, let's take it 12, then it is minus 7, so you will get 7. But if you take mod of this function mod, this will be okay, and this negative portion will also get reflected, this one. So now it will be 5, this will be 12. Now if you add, it is 5 plus 12. 17. Now you can obviously say if you take mod of the original function, this area becomes mod. So that is the difference. In this case, you are finding the area, then you take mod. So it is 5 minus 12 minus 7, then you take mod. And in this case, you are taking mod first, so it will become 5 and 12, both positive. Then you add, it is 17. So obviously this will be more than equal to this one. Equal to will be only negative is there. And when it is mixed positive negative, then it will be less. If you like the video, then press the like button and please give your valuable comments in the comment section.